Today we're going to look at symmetric boundary condition, which can be applied to a symmetry part, and also the fixed or support and the load are also symmetry. Let's get started. Let's start a new part. First, let's save the part. Symmetric. Where's your initial? Hit OK. Let's start with the sketch. So we know the part is a symmetry, so we only create the. We're going to use the front plane. We only create half of the part, right? So we would like to use some reference, so we will be able to locate our parts properly relative to the front, top, and right planes, right? So very simple. I'm going to use a part. Okay, so given dimension, say this is the half of the total length. We're going to use, say, 550 millimeter. Say, let's change the unit to millimeters. Okay, and then go back to sketch. Edit this sketch, 50 millimeter, and the height, say 30 millimeter, and make sure it's aligned with same as this one, right? So in the middle, so 15 millimeter. So it's lined here. Okay, then we're going to create 1, 2, and also there's one center, right? So hit OK. Give it dimension. Let's say this is 10 millimeter. 10 millimeter. And also 10 millimeter. Okay, you can see these two need to be positioned. So let's say from here to here, 20 millimeter, and from here to here, 40 millimeter. Hit OK. I'm going to just use this geometry at this moment, so you can see this one will be in the picture, in the drawing. It's a rounded. I'm going to simplify this as a square, so with corner at this moment. Now you can see I have a sketch. Then extrude. To 7. Okay. Let's save the file first. Okay, so here's the sketch, right? So extrude. Let's say we would like to use a sketch. Okay. This time we're going to use start from sketch plane and also use middle plane, right? So it will extrude in both directions. Let's say distance is 10 millimeter. Is okay. Right, this is my part. So save it. Now we need to assign the material. Let's say edit material. no material being assigned, alloy steel, apply, hit OK. Now alloy steel is my current steel. Okay, now what we need to do, we're going to establish our simulation, right? So go to simulation, start a new simulation. So you can see we only create the half of the part, right? So on which is symmetry about this plane, right? This plane. Okay. Now static 1 symmetric symmetry, right? So hit OK. Accept the default settings at this moment, and then we need to apply the fixed, right? So look at this condition. So we have load, we have a fixed pin, right? However, we only have one pin support here, so we're going to use pin or fixed here, and also apply load here. You can see here there's a small portion of this one being used for load. If you wish, you can create this surface. All right. So, but in my case, I just simplify this so it will be only applied on this cylindric load. Okay, and also we're going to apply symmetric boundary condition, so it will simplify our analysis with less mesh numbers, right, or no numbers. Okay, now fixed, we're going to fix this, hit OK. We're only one being fixed. If you have a full model, then you can fix this and a hole on the other side. All right, so we're going to apply open advanced, and then you can see advanced, right? Advanced, use the reference geometry and so on. So we're going to select symmetry. Okay, symmetry. Which one you're going to use for symmetry? This area. Okay, this is a plane, right? And this. Okay, all right. So you use this too. You can see it shows when you applied symmetry, then the other side will be created. Okay, to show the whole model, right? To show the whole model. So accept this. Okay. In reality, it's a full model, it's a full part, and in this analysis, in this study, you only have this solid. Okay. Save it. Now you have all the condition fixed. Now we need to apply the load. How to apply the load? You need to specify the total load and also the direction. So what we can do here, use force, okay, and it is force, right? So it will be this area and the select direction, right? It is normal to the force or select direction. We're going to select the direction which is on the top plane. Okay, and then we can specify newtons. So the newton we would like to make normal to the plane, right? Along the plane, and this one is along the plane direction 1 in x direction, in z direction, or in y direction, right? So we would like to have it normal to the plane, right? And specify the value. You can see when we room in, you can see it's going up, right? So then we need to reverse direction. Okay, reverse direction. So you can see here, Okay, the force being applied on this cylinder, right? So this is not actually the condition. The real condition is more close to apply the force on this area. Okay. Okay, let's accept this at this moment. Okay, Control 7. Save it. Now we have force load being, okay, external load being created. We're ready to run this simulation. Oh, we still need to create meshes, right? So create a mesh. Hit OK. All right. So this is a mesh. If you can see, if you have a full model, then the number of elements will be doubled, at least, right? Will be at least doubled, or normally, usually should be doubled. All right. We use the symmetry, right? Okay. Save the part, and then what we can do, we can run the simulation. Let's save the file first, and then run study. Okay, now we get to the result. This is the stress. You can see the stress is the highest close to here. What is the displacement? The largest displacement is about here, right? The strain. Okay, so this is the result. We can use, you can see in this study, we use the symmetry condition, boundary condition, to simplify our study. Okay, by use just half of the model to create it. All right, let's save the file. This is the tutorial 3, symmetric boundary condition.